Hi all, this is Dr. Shanthi, Professor, RMK College of Engineering and Technology. In this presentation, we are going to study about network topologies that are used in body area networks. Every network has a topology that determines the way in which different devices of a network are arranged and how they communicate with each other. Now, we have to know the difference between the two topologies, physical and logical topology. What do you mean by physical topology? The physical layout of a network, that is, the way the devices are physically connected to the network, either through actual cables or direct wireless communication link. Now, this is going to be called as the physical topology. By contrast, the logical topology of a network refers to the manner that the data flows through the network from one node to the other without worrying about the physical interconnection of the devices. The two layers of the OSI model, the physical and data link layer, define the physical topology of a network, whereas the network layer is responsible for the logical topology. Each topology has its own advantages and disadvantages regarding the network characteristics of a body area network, such as latency, robustness, capacity, and the complexity of data routing and processing. In practice, the topology is a choice of application design. The application developers have a balance sensor node cost. That is, they have to balance the sensor node cost, battery drain, complexity of routing, robustness, scalability, latency, mobility, and spatial coverage. Now let us see the overview of the various network topologies that are available or that are applicable to wireless sensor networks, otherwise called as body area networks. The first one is a point-to-point network. The simplest topology consists of only two devices directly connected with each other. So this is one node and this is one node. So these two are connected directly. Now next comes what is called as the star topology or the star network. In the case of a star network, there is a central controller called as the coordinator or the master. The peripheral nodes are called as slaves. All the slaves can only communicate with the master. Communication between the slaves requires passing all the data through the master. Next comes mesh networks. In the case of mesh network, any device can communicate with other devices as long as they are in the range of one another. Now this is the other name for it is peer-to-peer network. Multi-hopping networking protocols enable routing of packets from one device to the other. So say this device can communicate to this node. Say from here the communication can take place to this node. So it is a multi-hop network. Now coming on to the next topology, which is star mesh hybrid network. So when you look into the diagram, this part of the diagram is a star network. Now this part of the diagram is a star network. Now in the middle you have what is called as a mesh network. So the star mesh network, it allows connecting a mesh network with one or more star networks. So a mixed star and mesh network combines the simplicity of single hop of star topology while the extendability and flexibility of multi-hop mesh topology. Now this provides high degree of mobility for star clusters. The next one is going to be called as cluster tree network. The cluster tree topology is a special case of multi-hop mesh network where there is always only a single path between two devices. The first device starting the network becomes the root of the tree, Another device can join the network as a child of the root node and in turn allow other devices to join the network through that device. Devices are aware of their parent node and any child nodes. This hierarchical topology reduces routing complexity. Now, when you look into the diagram, see here, now this is the parent node, right? And these are its children nodes. Now, this is aware of its parent node. Thank you.